Hello. Today we will be looking at a MicroCT and how we use it in the FIAM research group here at the IFM. On the right you can see a photo of the MicroCT we have at the Maxwell Center. MicroCT is a 3D imaging technique utilizing X-rays to see inside an object, via slices. MicroCT, also called microtomography, is similar to hospital CT imaging but on a small scale with greatly increased resolution. A CT scanner in hospitals as shown here, can be used to study all parts of your body, such as the chest, belly, pelvis, or an arm or leg. It can take pictures of body organs, such as the liver, pancreas, kidneys, bladder, lungs, and heart. It also can study blood vessels, bones, and the spinal cord. In a MicroCT, samples can be imaged with pixel sizes as small as 100 nanometers. And objects can be scanned as large as 200 millimeters in diameter. This is great for research as you can look at anything you want, from fluids to metals and even samples such as a bee's stinger. Current research taking place at the IFM is looking at embedding material into ceramic tiles in different material formats using various deposition techniques, including an inkjet printer and an automated robot as seen in the video. The mold for the ceramic tiles are filled halfway with porcelain ceramic powder and then the material is deposited on top. The top image shows deposited paste and the bottom shows wire. This will be embedded by filling up the mold with more porcelain ceramic powder and then compressed into a tile as shown on the right. As you can see, once the tile has been compressed you can no longer see what the material looks like inside the tile. So let's see what the MicroCT can show us. On the right, this is the overview of the tile using the MicroCT, but you still cannot see what is embedded in the ceramic. However, this can change once you start adjusting the settings with the MicroCT software. Once the settings were adjusted, you can now see the embedded material. The image on the left shows a wire pre-firing, on the right you can see the wire post-firing. This change in physical properties could not be seen when you look at the ceramic tile, but could be seen clearly when it was put through a MicroCT. So let's see the MicroCT in action. Here you see an everyday object you can find, a flower. The flower is clamped and placed in the middle of the MicroCT. On the left of the flower is the source, and on the right is the detector, and these are used to scan the flower. Once the flower is securely placed, it is time to find the right settings to start the scan. This can include the exposure time, the power level, voltage, and establish if any filters are needed, depending on the intensity levels of the sample when referenced. Once the settings have been selected, the scanning can start. These scans can range from 20 minutes to more than 10 hours, depending on exposure time and how many projections you would like to achieve. For this flower we did a quick test of 30 minutes. Here you can see the final scan. This image shows the flower before any adjustments. You can still see the clamp and the foil, and therefore this was cropped out and the grayscale levels were adjusted to achieve this image. The videos show the 3D scan of the flower in grayscale and in color. The 3D image shows the fine details of the flower. Let's have another look of an everyday object, a mobile phone. What you can see here is the outsides of the phone, which shows a camera, speaker, headphone port, and charger port. Let's open it up and see what is inside. We have a battery, and behind this is the back of the phone screen. So let's MicroCT this and see what we get. Here you can see a 2D image that was taken when getting the phone ready for scanning. Note here that we can still see more than what we could originally when just looking at the phone with a naked eye. We can see here the camera, the plastic covering, a few resistors and capacitors. Let's see the 3D image. Here you get more detail of the phone, you get more depth and understanding of how the phone is connected, so that you can use the camera and microphone and use the ports for headphones and chargers. It gives more details of the PCB, but what is more interesting is how much is going on in a very tiny space that we cannot see. If you look at your phone and compare it to the past generations of phones, they are only getting slimmer and smarter, such as having touch screens and NFC tags. Hence these hidden details within the phones are only getting more complicated and smaller. You can even notice that in the newer phones you cannot remove the battery anymore. Thank you for watching. I hope you enjoyed this talk on MicroCT.